Good morning, children. Good morning.
Good morning, ma'am.
Good morning. Please, anyone, please read the last classwork.
Steve is in the waiting room.
Okay, admitted. I admit him. Okay, children, so we have already studied three congruence rules. Which are they? And Leah, which are the three congruence rule that we have studied?
SAS congruence rule.
What is SAS congruence rule? SAS congruence rule, and Leah, what is it?
Ma'am, two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle.
Okay, that is a SAS congruence rule. Then, Michelle, next congruence rule is what?
ASA.
ASA. ASA congruence is what, Michelle? Michelle, ASA. Michelle?
Yes, ma'am.
ASA
Two triangles are
congruence.
congruent if two angles on the included sides of the one triangle are congruent equal to the two angles on the included side of the other triangle.
Shivanya, next one.
AAS congruence rule.
What is
Two
that?
triangles are congruent if any two pairs of angles and one pair of corresponding side is equal to two pairs of equal angles and corresponding side of the other triangle.
Okay. Children, only five can switch on, all others having network issues. I won't give attendance if you are not switching on your videos.
Ma'am,
Yes.
ma'am, I'm having some problem.
Okay. Others also having some problem. I won't give attendance. Or otherwise, you ask your parents to call me. Only after that you will get attendance if you are not switching on your video. Clear? Okay. Now, Gobi, read the question. Gobi. Gobi, read the question.
Yes, ma'am.
Uh.
Ma'am, in right triangle ABC, right angle at C, M is the midpoint of hypotenuse AB. C is joined to M and produced to a point D such that DM is equal to CM. Point D such that point D is joined to point B, show that triangle ABC congruent to triangle BMD.
AMC, wait. Triangle AMC is congruent to triangle BMD. That is the first question. Okay. So in triangle ABC, what is given? Given is triangle ABC. This is the triangle ABC. And in triangle ABC, right angle at C. All of you mark right angle at C in your figure. Right angle at C, and M is the midpoint of hypotenuse AB. M is the midpoint of hypotenuse AB, and C joined to M. CM. We are producing. See, we have a right triangle ABC. A, B, C. And M is midpoint of AB. We are joining CM. Then what? and CM is
Produced to-
produced to a point D. Produced a point D such that DM and CM are equal, and D is joined to B and yes, D is joined to B also. So this is our figure. Now we need to prove triangle AMC congruent to triangle BMD. All of you move your fingers through AMC. Which is AMC? Move your fingers on triangle AMC in your figure. AMC. This is the first triangle. AMC. BMD. BMD. All of you understood what is the which are the two triangles? AMC and BMD. Okay, that's okay. So now we need to prove AMC triangle AMC is congruent to BMD. Okay. So start. What are the arguments?
Equal to BM. The M is the midpoint.
Yes. Consider triangle AMC and triangle BMD. That is our first question we need to prove. Okay, Mithun, what you said?
Ma'am, AM equal to BM.
BM, AM equal to
M
BM
is the
because M is
midpoint.
the midpoint. Okay, that
Ma'am,
was
so D and C also we can do like that. MD equal to CD.
AM
BM is
equal to BM.
CM.
AM equal to BM. M is the midpoint. Okay. Then
Ma'am, DM is equal to
DM equal
CM.
to CM.
DM equal to CM.
DM.
It is given. Okay, good.
Yes.
DM
So
equal
both
to.
are corresponding, so it can be vertical.
We have two sides we got.
Yes.
SS congruence is not there. Two sides are congruent. We can't say they are congruent. With only two sides, we can't say they are congruent. DM equal to CM. What next? Given. Mithun, here we have only two corresponding sides are equal. Such a congruence rule is not there. We have ASA, SAS, and AAS.
And angle AMC is equal to DMB.
Angle AMC equal to DMB. What was the reason?
Yes.
Vertically opposite.
Very good,
Vertically.
very good. These two are vertically opposite angles. So we can write angle AMC equal to angle DMB, vertically opposite angles. Vertically opposite angles. So we can say triangle AMC is congruent to, is that including angle? That vertically opposite angle? Is that the including angle? Yes. See, these two are the sides. So this is the including angle. Okay. So triangle AMC congruent to triangle BMD. Which congruent rule? By which congruent rule?
SAS.
SAS. SAS. By SAS congruence rule, those two are. Okay. Next we need, is it over?
No, ma'am. Ma'am, test is during the last period.
Tested last period. Chapter polynomials, no?
No, ma'am, number
No.
system.
Which one? Number system.
number
First
system.
one, yes, first chapter. Polynomials is not there for this term. Okay. Over? Can I continue?
Yes, ma'am.
Okay. See, next question we have to prove that angle DBC, which one this one? DBC. This angle is 90 degree that we need to prove. DBC. Okay. For that, all of you listen, all of you look at the figure. See, See, these two triangles are congruent that we have proved. Which are they? AMC and DMB are congruent. So angle ACM equal to angle BDM. Can I say that? Can I write this statement? Angle ACM equal to angle BDM. Is that correct or not? Angle ACM, this angle. These two triangles we have proved congruent in the first question. And these two angles are equal. Can I say these two angles are equal? ACM and BDM.
No.
ACM
And they
and
are equal.
equal. Why?
Alternate interior angles.
No. Alternate
90
interior angles means we don't know whether DB and AC are parallel.
Ma'am, 90 degree.
90 degrees, this total angle is 90 degree. ACB is the 90 degree angle. So how can I say, by which reason can I say these two angles are equal?
CPCT.
CPCT. By CPCT, I can say by CPCT because we have already proved AMC and BDM are congruent triangles. So by CPCT, then I can say. Now, Michelle, your argument is correct. If these two angles are equal and they are the alternate interior angles, so we can write DB parallel to AC. First of all, we can't say alternate, they are alternate interior angles, but they are equal, we can't say, because it is not given AB and AC are parallel. We have to prove that. Okay. So since alternate interior angles, by CPCT, we can say they are equal and they are the alternate interior angles also. So by converse, since alternate interior angles are equal, we can say DB parallel to AC. Is that clear, all of you? In bracket, you can write angle ACM and angle BDM are alternate interior angles. Interior, they are the alternate interior angles. So DB parallel to AC. If DB parallel to AC, what about these two angles ACB and DBC? These two angles are, what was the name of these two angles? ACB, AC, AC and
Can
DB.
you explain one more time?
Which one? Which point, Vinayak?
Angle ACM equals to.
Angle ACM equal to BDM. See, angle ACM and angle BDM are equal by CPCT because we have already proved ACM and BDM are congruent triangles. They are equal by CPCT. And we know, see, DB and BD, DB and AC are two lines and CD is a transversal. So this forms alternate interior angles. And we got alternate interior angles are equal, which means what? If alternate interior angles are equal, conversely, we can, using the converse, we can say DB parallel to AC. Okay. These are alternate interior angles and we got alternate interior angles are equal. So DB is parallel to AC. And if DB parallel to AC, these two angles are co-interior angles or interior angle on the same side of the transversal. So we will write angle ACB plus angle DBC equal to 180. Interior angle on the same side of the transversal. Reason, interior angles on the same side of transversal. Same side of the transversal. But it is given that ACB is right angle. So 90 plus angle DBC equal to 180. Angle DBC equal to 180 minus 90. Angle DBC equal to 90. So this also both are 90 degree. B and C are 90 degree. First of all, we are taking ACM and BDM are equal by CPCT. Since they are equal, the lines are parallel. So DBC and ACB are interior angles on the same side of transversal and their sum is 180. And given that ACB is 90 degree, so 90 plus DBC is 180, DBC is 90 degree. Okay, next question is what? We have to prove triangle DBC congruent to triangle ACB. All of you look at those two triangles DBC and AC. Can I rub this? Is it over, all of you?
Yes, ma'am.
Triangle DBC. Triangle DBC. Move your fingers through DBC. DBC. This is the triangle DBC. And triangle ACB. ACB. Understood? Which are the triangles we are considering? Consider triangles. Consider triangle DBC and triangle ACB. Triangle DBC and triangle ACB. Okay, now try to prove their congruence. One by one argument, say anything are equal.
B and C are both 90 degree.
90 degree, good. We can write angle DBC. We have just proved angle ACB is 90 degree. Then
And DBC is also 90.
D.
Oh, yes, ma'am. That both are 90 degree.
Yes. D. Which one? Which one do you said?
No, ma'am, the same I said, DBC and AC.
DBC and ACB. Anything else?
Ma'am, BC is equal to BC.
Very good. BC is common to both. BC equal to BC, common. Then? Then? Any other angles are? Think. One side and one angle are equal, that we got. Is anything common again? Anything else common? No. What about DB and AC? Are they equal? DB and AC. Or can we say DB sides, DB and AC are equal? Hmm? Can we say, Alan? Can we say DB and AC are equal by any reason? Can we say DB and AC? Or they are equal. You find out what was the reason. AC or DB equal to AC. What was the reason? Give the reason. They are equal. How? How can we say? DB equal to AC.
Ma'am, opposite.
Opposite?
Corresponding sides.
Yes, because see, we have proved these two triangles are congruent, isn't it? ACM and DBM are congruent. ACM and DBM are congruent. So the DB and AC are their congruent parts. So by CPCT, we can say DB equal to AC. DB equal to AC. Reason, triangle AMC congruent to triangle BMD. So DB equal to AC, CPCT. See, side, angle, side, side, angle, side. So triangle DBC is congruent to triangle ACB by SAS congruence rule. By SAS congruence rule, DBC is congruent to ACB. Okay. Okay. Now, last question. Last question, we need to prove CM equal to half AB. CM equal to half AB. See, we have already proved DBC is congruent to ACB. So we can write DC equal to AB. DC equal to AB by CPCT. DC equal to AB by CPCT. But we know that M is the midpoint, given that DM and CM are equal. M is midpoint of DC. Okay, so DC, I'm writing 2, DC is 2, DC is 2 CM. DC equal to AB by CPCT. DC we can write 2 CM because DM equal to CM. So DC equal to 2 CM. So CM equal to half AB.
And this is now we are writing fourth one, right?
Fourth one.
Ma'am, can you explain it one more time?
Yes. See, we have proved DBC and ACB are congruent. Third question, DBC and ACB are congruent. Okay, so we can write DC equal to AB, congruent parts. From here we can write DC equal to AB, CPCT, clear? CPCT, okay? Now, DC is what? This line. DC is this line. And M is the midpoint. So, DC means 2 CM. Clear, Shivanya?
Yes, ma'am.
Okay. So, DC means 2 CM. DC is total. CM and MD are equal. So, DC we can write 2 CM. 2 CM equal to AB. So, CM equal to half AB.
Okay.
Is that clear, Vinayak and Leah? Is that clear?
Yes, ma'am.
Now, children, now we are moving to the next part of the chapter. Write theorem 7.2.
And page number.
Page number, 1 second. Let me check.
Attendance.
Attendance, I am taking the attendance.
And we should write 7.2.
I took the photo and attendance is only for those videos are on. Okay.
Ma'am, I'm having net issue.
Okay, Alia, you have already informed me. Okay, children. So write 7.1. We will discuss that later during next period. Okay.